Radio telescopes are revealing a trove of faint circular objects in the sky, and this is what they look like. Radio astronomers see what the naked eye cannot see. As we study the sky with telescopes that record radio signals rather than light, we end up seeing a lot of circles. The newest generation of radio telescopes, including the Australian Square Kilometre Array Pathfinder, ASCAP for short, and Meerkat, a telescope in South Africa, is revealing incredibly faint cosmic objects never before seen. In astronomy, surface brightness is a measure that tells us how easily visible an object is. The extraordinary sensitivity of Meerkat and ASCAP is now revealed in new low-surface brightness universe to radio astronomers. It's comprised of radio sources so faint that they have never been seen before, each with their own unique physical properties. Many of the ASCAP results presented here were obtained with one of its major observing programs called EMU, Evolutionary Map of the Universe. EMU is mapping the entire southern sky with an unprecedented sensitivity and will deliver the most detailed map of the southern hemisphere sky to date, a spectacular new radio atlas that will be used for decades to come. EMU's all-hemisphere coverage paired with ASCAP's exceptional sensitivity, especially within the Milky Way galaxy, our galaxy that is what's yielding so many recent discoveries. And here's what they're teaching us. The ghostly rings Kyklos, from the Greek Kyklos, circle or ring, and the object WR16 both show the environment of rare and unusual celestial objects known as Wolf-Rayet stars. When big stars are close to running out of fuel, they become unstable as they enter one of the late stages of a stellar life cycle. They become a Wolf-Rayet star. They begin surging and pulsing, shedding their outer layers, which can form bright nebulous structures around the star. In these objects, a previous outflow of material has cleared the space around the star, allowing the current outburst to expand symmetrically in all directions. The sphere of stellar detritus shows itself as a circle. Stingray 1, Perun, Ancora, and Unicycle are supernova remnants. When a big star finally runs out of fuel, it can no longer hold back the crush of gravity. The matter falling inwards causes one final explosion, and the remains of these violent stars' deaths are known as supernovas. Their expanding shock waves sweep up material into an expanding sphere, forming beautiful circular features. The supernova remnant will be deformed by its environment over time. If one side of the explosion slams into an interstellar cloud, we'll see a squashed shape. So a near-perfect circle is a messy universe. In a messy universe is a special find. Delios, named after the Greek delios meaning perfect, for its near-perfectly circular shape, is shown. This unique object has never been seen in any wavelength, including visible light, demonstrating ASCAP's incredible ability to discover new objects. The shapes indicate Delios has remained relatively untouched by its environment. This presents us with an opportunity to make inferences about the initial supernova explosion, providing rare insights into one of the most energetic events in the universe. At the other extreme, we can take an object and discover something entirely new about it. The Diprotodon supernova remnant is also shown. The remnant is one of the largest objects in the sky, appearing approximately 6 times larger than our moon. Hence the name, the animal Diprotodon, one of Australia's most famous megafauna, a giant wombat that lived about 25,000 years ago. ASCAP sensitivity has uncovered the object's full extent. This discovery led to further analysis, uncovering more of the history and physics behind the object. The messy internal structure can be seen as different parts of the expanding shell slam into busy interstellar environment. A cosmic mirror. Lagotis is another object that can show how new telescope data can reclassify previously discovered objects. The reflection nebula VDB80 has been seen before within the plane of our Milky Way galaxy. The light we see was emitted by nearby stars and then reflected off a nearby cloud of gas and dust. However, when newly available ASCAP EMU data, with new data, we were able to discover an associated cloud of ionized hydrogen known as H11 region, pronounced H2, where stellar energy has caused the gaseous matter to lose its electrons. This H2 region is seen to coexist with the reflection nebula sharing the same stellar center and is created from the star pushing into a molecular cloud. And this movement is akin to burrowing, so the object earned the name Lagotis after Macrotis lagotis, the Australian greater bilby. Outside the galaxy, ASCAP and Meerkat are also illuminating objects from outside our Milky Way galaxy. For example, radio ring galaxies. When we use visible light to look at the stars in this galaxy, we see a rather plain disk. But in radio light, we see a ring. Why is there a hole in the middle? Perhaps the combined forces of many exploding supernovas has pushed all the radio-emitting clouds out of the center. We're not sure. We're looking for more examples to test our ideas. Finally, LMC ORC is an odd radio circle ORC, a prominent new class of objects with unfamiliar origins. Only being visible in radio light, they are perhaps the most mysterious of all. The next generation, Meerkat and ASCAP, are revealing incredible insights into the low surface brightness universe. However, they are precursors of the Square Kilometre Array, an international collaborative endeavor that will increase the abilities of radio astronomers and reveal even more unique features of the universe. The low surface brightness universe presents many mysteries. These discoveries push our understanding further. Currently, the EMU survey using ASCAP is only 25% complete. As more of this survey becomes available, we'll discover many more unique and exciting objects, both new to astrophysics and extensions to previously known objects. This is from the conversation. This is by Miroslav Filipovic, Professor, Western Sydney University, Andrew Hopkins, Professor, Astronomy, Macquarie University, Luke Barnes, Senior Lecturer in Physics, Western Sydney University, and Nicholas Tarthill, Associate Professor, Western Sydney University, on Science Alert. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.